Looks like it's time to start. All right, good to go. Hello, everyone. Thanks for coming. My name is Kent Miller. I work for Digital Globe, and I'm just going to be talking to you about a project we have called GeoWave. GeoWave is an open source framework, basically intended to connect the geospatial intelligence community with their goals of getting into big data. So whenever I use the word geospatial, my normal audience, that's their life. They know what that means. But what I want you guys to think of when you hear geospatial, think n-dimensional coordinate. So whatever that data is that you're working with can kind of be swapped in there. So I need to give you a little bit of bio, not to establish my credentials, but to set your expectations. What I wanted to tell you is that this is actually my first time speaking at a technical conference. So I'm normally sitting behind a desk coding away. Thank you very much. Just moved up here from San Diego this past weekend, so I'm just a little frazzled in every possible direction right now, but living in an Airbnb, so. I do quite a bit of public speaking, but it's usually to a much smaller room and much smaller people. In fact, since my actual presentation is so short, if you wouldn't mind me indulging myself, this is actually something I'm really passionate about. I work as a volunteer for an organization called Junior Achievement. They go into schools and they basically start training kids at about 5th grade to do money management, learning how to run businesses. They have this cool place called BizTown where they get to spend the day, managing a business, things like that. And they also sponsor professionals to go into the middle schools and high schools to talk about careers. So what I love doing is going into the middle schools and high schools and talking about software as a career. I love the 6th graders because they always want my autograph afterwards. Kind of cool. But anyways, the reason I'm passionate about this is because on the plus side, you guys have all heard the term STEM, right? Science, technology, engineering, and math. It's a big push in the schools now, which is fantastic. The problem with that is that those words, science, technology, engineering, and math, tends to immediately put a thought into a student's head, and a lot of them say, oh, that's not me. So what happens is the creative kids, the kids who don't think of themselves that way, and by and large, the young ladies, they just don't get excited about these kinds of careers. So what I like to do when I go in these classrooms is go into like the art classes, the English classes, things like that, and really kind of sell these kids on the idea that you don't have to be, the engineer type to consider this career. I actually was in my 3rd year at Cal Poly as an architecture student when I took a summer job at IBM Federal Systems here in Sunnyvale and started writing Fortran code for satellites and completely changed my direction. And so it's kind of like my little soapbox I like to get on. So what I want to encourage you guys to do, you all have influence into some kid's life, whether it's your own children, neighbor's kid, you coach a soccer team, baseball team, whatever. Kind of look for those opportunities to let them know that the opportunities are unbelievable in this field now, and they just need to think about it. I have 2 children of my own, 2 grown daughters. One's a lawyer, but we knew she was going to be a lawyer when she started speaking, so she was a lost cause. But I'm very happy to say my younger daughter just finished her 1st year as a web developer at a biotech firm down in San Diego. So I'm 1 for 2. So just encourage you guys to get the word out there. As I mentioned, I've been in satellite modeling and collection management for a long time. I have very little time in big data, probably on the order of 3 or 4 months. I was added to the GeoWave team to work specifically on the sort of the mapping side. But I really wanted to come to this conference and learn more about big data, and my boss said, well, you can go if you give a talk. So here we are, and I apologize for that. Anyways, GeoWave was developed for the geospatial intelligence community. They were gracious enough to say, this is awesome, let's open source it. So we've been out on GitHub under NGA GeoInt for probably a couple of years now. Just last week, we moved over to Location Tech. So at the end, I've got some links for you, but if you go to GitHub, Location Tech, you'll find GeoWave there. A lot of good resources. By the way, this is also GeoWave's first appearance at a big data conference. We usually go to like the location techs and that kind of thing. So that's my intro. This is probably a 10-minute presentation total. So what is GeoWave? GeoWave is that. It's an open source framework. It's intended to basically connect big geospatial data sets with key value stores. That's the elevator speech. And the way we implement that is through what we call a space filling curve. And hold on one second. OK, we're good. Just checking my slides here. So there's a bunch of academic work on space filling curves. There's a bunch of different ways to do it, probably 6 really good ones. We picked the best 2, and we implemented this. So the idea is that you can take any number of dimensions. In this case, pretty simple example, we're using latitude and longitude. And things that are close together spatially in latitude and longitude end up close together in the key. So it makes basically a query against a small spatial area will be very quick because the row range will be small. And so what GeoWave does at its core, all it really does, and all you need to do to have felt like you got something out of this presentation is understand that we're doing this mapping that goes from an n-dimensional coordinate system to a sortable key. And that's the black box, that's the magic. Probably 90% of what we do for our customers is in this lat long space. Lat long and time. It's basically those 3 dimensions. So we just do this decomposition from one to the other, and the rest is just sort of the infrastructure that makes it all happen. All right, so let's talk about the highlights of GeoWave, what you kind of get with it. As I mentioned, it's an open source extensible Java library. If you have Java developers, if you have an investment in Java, it's pretty easy to start using it. On the last slide, I mentioned this 2-way mapping between your geometry and an index. Let me just step aside and talk about this n-dimensional thing just a little bit. So you can basically treat anything like a dimension. One of the demos that we have uses, I don't know, 3 billion different data points from the New York Taxi Commission. So it's basically, it's a location for pickup, a location for drop-off, and a time on each end. So if you take all 6 of those, you get a 6-dimensional index. And that makes it really easy to query against a lot of data like that. I don't know if any of you are familiar with moving target indicator data, but it's basically like a motion detector. You get a point in time, but you also get some sensor parameters with it. And the sensor parameters are kind of important, like signal to noise and like range velocity, stuff like that. So for the analysis part, you really need to know those things. And so finding those things close together is important. So we end up with a 5-dimensional index for that kind of stuff. Okay. We provide some plugins for the common geospatial formats. So if our clients tend to have a lot of shape files and GeoJSON and all the normal kinds of map type data. Anything that's in those we provide, plus a bunch of raster stuff for maps and imagery, things like that. We provide a command line interface, so when you're logged into your Edge node or whatever, you can basically just script these things. And I'll break that a little bit more for you later on. Sort of the cornerstone of this whole thing for our community is this GeoServer plugin. And if you're unfamiliar with GeoServer, it really is just a web application, runs on an application server, and it serves up map data through the Open Geospatial Consortium standard interfaces. So WMS, WFS, Web Map Server, Web Feature Server, those kinds of things. That community is already kind of plugged into that. So for us to provide this connection to big data through GeoServer was a natural thing. And we can talk about that a little bit more. For each data store type, we support Accumulo, HBase, Bigtable, Cassandra, DynamoDB, and we have more on the way. And each one gets its own distribution that goes with the data store, just to enable things like custom iterators and Accumulo and coprocessors and HBase, stuff like that. We have some MapReduce code in there, integration tests and samples and things like that, so you can build your own jobs. The next 2 bullets I'll talk about in more detail on another slide, but basically it's sort of alleviating the bottleneck for getting lots of data into a map, the distributed rendering and the subsampling. We provide scripts and RPMs if you want to deploy the stuff on AWS, and then we also have a bunch of documentation, tutorials, things like that. All All right, so what do you get out of the box? If you just deploy GeoWave on your cluster, you basically get a GeoWave core that's connected to your key value store. You get the command line interface, and you get the GeoServer plugin. From the command line, you can do things like configure your data stores, your indices. You can ingest data. You can manage your data stores. You can run some query debug type stuff to make sure your data is getting in there like you expect. And you can export vector data to different formats and so on. And then on the GeoServer side, as I mentioned, we provide these standard interfaces for these different things that the geospatial community kind of expects. If you're going to extend GeoWave to do other things, and I think you guys would probably all be in this boat because you're going to have things other than geospatial data, I imagine. We have a GeoWave GeoWave input format, GeoWave output format that basically are a MapReduce extension, so then you can create these inputs and outputs for whatever you want. So we put together some samples for things like Twitter and PDAL point cloud data. I mentioned the New York Taxi Commission stuff. There's some other stuff in there for you to look at. You can either extend them or copy them or whatever you want. And on the analytics side, GeoWave is not really doing much in terms of analytics at this point. It's really more the data platform. But we do provide a handful. We have the k-means clustering. We have kernel density estimate, and maybe 2 or 3 others that do similar kinds of things with clustering and heat maps. We provide some hooks into basically pulling data out of your GeoWave data stores into an RDD, either in Scala or in Java. So that kind of opens up this whole Spark side for you. And then, of course, the GeoTools is sort of the foundational library underneath GeoServer, so we have a lot of customers that just kind of extend at that level. OK, so this is a question that a lot of people actually have. When you're talking about billions of points, sure, you can ingest it fast, you can query it fast, but it still ends up taking forever to actually make a map. Well, what you end up having is this bottleneck at GeoServer, because GeoServer is not really a distributed thing. It just sits on a server and kind of serves up stuff like any web server would. So we provided actually two ways to deal with this. The subsampling just basically says, given the number of pixels I have to fill in my current map or my current view, as soon as I fill that pixel, I can skip ahead to the next coordinate in the space filling curve. I don't have to deal with any of that stuff. So if you imagine you've got a couple of billion points over New York City, but your map on your web page is only 1,000 pixels by 800 or something, you're going to have a whole bunch of data represented by that one pixel. So as soon as you hit the pixel, it's filled in, you just move on. And that allows you to skip a lot of data. You really are just doing the map rendering. You don't care about all those points that would just duplicate that pixel over and over. And those are implemented as basically custom filters or iterators on the back end. And also for the distributed rendering, what you'd normally do if you didn't have GeoWave, you would query all this data across your cluster and pull it all into GeoServer, and then it would have to sit there and painstakingly grind out this tile or these sets of tiles. What we do is we just allow each of the nodes to render the data that they have, and then they pass back a tile. So it's a lot quicker. And then GeoServer just composites the tiles for you. So it's just some ways to do fast rendering. Not necessarily applicable to things other than maps, but if you're doing a lot with big images, the tile rendering is certainly helpful. And I have a video that doesn't have sound. It's just kind of what I just said, so we'll skip the video. I do have a sample of the New York taxi data. This is basically the output of the kernel density algorithm. So we ran those 3.5 billion points, and it just came back with this heat map. So as you zoom in and move around, it'll resolve into, it'll go query those tiles and pull them in. And as you can see, it's probably 30-minute job to process the heat map from those points, and then from then on you've got this tile set that just acts like any kind of map. So Okay. So this is kind of in summary at its core, we're just bridging this gap between the geospatial community and platforms and the distributed processing groups. Not sure if any of those names on the left mean anything to you, but I'm sure you're familiar with the right-hand side. Where we're headed next, I mentioned Cassandra and Dynamo. We actually have initial support for those. The full support is in integration and test now. So probably the next release will have full support for those. And in the future, we're looking at some of these other things, which honestly, I can't answer any questions about those. So on the analytics side, we are going to start getting a little bit more heavily into the Spark side, extending our work on the RDDs to provide some more analytic examples, and trying to get the word out. So, okay, we just, as I mentioned, moved to Location Tech last week. We're going to be presenting a paper at the SSTD in next month, I think, and then we'll be at Phosphor-G, which is the, was it free and open source software for geospatial, or for government? Does the G stand for government? I don't remember. Anyway, that's what's coming up for us. All those links up there are our new links. So we got github.com, Location Tech for the source, and then documentation, et cetera. So Rich Fetcher is actually our lead technologist on GeoWave. He basically wrote almost all of it. He's the best one to email with real questions. But if anything I said is confusing or needs a little smoothing over, let me know. Anybody? Yeah, right here.
So you create an index
Uh-huh.
based key value. So the key value store has the input data.
Yeah.
And where do you store the index? Is it your own store, or you put it back into the same key value?
Can you repeat the question?
Okay, so the question is the index stored by us also in the, yeah, we just use multiple tables within your data store. So we have like a metadata table, we have an index table. Yeah, they're all stored in your data store. Yes, back here.
Sure. How do you plan to invoke the GeoServer from Spark? Is it going to be a library under GraphX, or?
I can't hear you, I'm sorry. There's a microphone right here.
Oh, I'm sorry. Yeah, hey, how do you plan to invoke GeoServer from Spark? Is it via the GraphX library or otherwise?
GeoServer has a RESTful API, so that's the easy way.
Okay.
Right here.
How is this different than GeoMesa?
So the big difference between GeoMesa and, I'm sorry, the question is what's the difference between GeoWave and GeoMesa? GeoMesa is specifically geospatial, so it's lat long, period, lat long time. So that is essentially the difference, is we are extendable to n-dimensional data, whereas they're focused specifically on the geospatial side.
So follow-up question is, has this been used in any other industry? Like, is it only for spatial kind of? Is this only for spatial work, or do you use like for any data that has n dimensions, like medical data for that matter?
You guys heard the question. The intent is that it can be used for any n-dimensional data. What it's been used for in practice so far has been essentially spatial data lat long time, and also point cloud data, so XYZ time, LiDAR data sets kind of thing.
So I think you guys are using Hilbert transformation, and most of the examples are like points, and you keep saying n-dimensional. So do you guys, right now, if I want to do like polygon transformation, does it support, like GeoWave support polygon transformation? So rather than lat long, what I have is like a building footprint. Like if I want to just geospatial index that, can we do that today?
Yeah, I mean, any kind of, you're just talking about any kind of multi-geometry kind of shape. Yeah, we support everything that GeoServer supports, so any kind of polygonal data, line data.
So following on that, will you be able to do like a polygon in polygon search or a point in polygon search on the grid? using this libraries? Like-
I'm sorry, I can't.
What I mean is, for example, I have a list of neighborhoods, for example, and I have a list of taxis lying out there, and I want to figure out which neighborhood is each taxi and kind of stuff. And I have tons of these neighborhoods or small polygons, and I want to basically rapidly find these points, find which polygons these points fall in, and extending it to polygon in polygon search. Does this support all that, or?
Yeah. So you're just talking about
Yeah,
multi-polygons. So yeah, yeah. So, and we, I don't think we restrict how many filters you can apply.
Yeah, two questions.
Huh?
One is how do you do incremental update? Second one is how do you maintain your index consistent with your data?
For incremental update, that's a good question. We are just about to release version 1.0. So we do have, we just got our own DevOps guy, so we'll be figuring that out shortly. And the second question was how do we maintain the,
Yeah, how do you maintain that your index is consistent with your data? So if your data changes, how do you update the index so they are consistent?
That's a good question. I actually don't know the answer to that. I would have to guess that if you're changing the index, then that would become a new record. I mean, this would be something for your programmers to deal with, I imagine. But that may not be true. I'd have to find out.
So where do we run the visualization? Do we point it to HBase and index, or do we run it off your server?
Well, it's your server, and
The server, right, which means stuff for the geo thing, right, but it runs on the edge node. So after you build the key value pair, how does the visualization run? What do you point it to? Means or then which data source do you point it to? Do you point it to HBase, or do you point it to the key value pairs which you build?
well, it's all in HBase.
Okay.
So
So even the key value pair is in HBase?
yes,
Okay.
yeah. Did you guys miss that slide where I said I don't know anything?
Just to follow up on that, so the polygon and polygon rendering on the visual, it's on our database, I mean the application database on HBase and not on your server?
So the tile rendering, see if I can describe how this works. So let's say you've got HBase and you're running on 100 regions. And what happens is that it actually goes out like a query. So each one gets its own row range, and it grabs that data for that region, and it'll generate a tile. It basically runs like an aggregator, and then it'll just generate that tile, and that tile gets sent back to GeoServer. GeoServer just collects everything from that sort of federated query and makes the final tile out of it. Does that answer your question? Okay. Anyway, I'd love to get off this stage, so. Thank you. I'm never doing this again, but thanks for coming. I'm actually happy to answer questions. I just prefer to do it without a microphone, so.
Check, check, whoa. I'm a loud guy. Okay, I'm usually pretty loud, so, if we adjust it, keep going, check, check, check. Hello? Keep going? Oh, that's good. All right. Okay, check. Okay, that better? No, not yet. Check. Hello? Check. Hello? 1, 2. Big data? Okay. Better? Keep going? All right. All right, thank you.